So I did problem number 7 in chapter 11 for inference for single means. So for this problem, we are going to construct a 95% confidence interval for the ages and years of the 25 customers. So first we'll check the conditions. So the independence assumption is satisfied because this is a random sample and one customer's age should not impact another customer's age. The randomization condition is also satisfied because the customers were randomly selected. The nearly normal condition is also satisfied, even though our sample of 25 is not quite 30, but we can see from the histogram and the jump output that the histogram is roughly symmetric and that is unimodal and with no outliers. So we can see that our DF is 24 from the sample size, and we get a mean of 31.44, which we can see in jump. Our standard deviation is 10.12. We have a median of 32, and we can calculate the standard error to be the standard deviation divided by the root of n, which is 2.02, which we can also see in jump. And by answering the problem's question, if the sample size increased to 100, the standard error would decrease and the confidence interval would become smaller. So we can see that the histogram is approximately normal. Like I said before, we have no outliers as indicated by the box plot. And if we decide to conduct a goodness of fit test, our H0 will be that the ages come from a normal distribution, whereas our alternative is the ages do not come from a normal distribution. So by doing a goodness of fit test for this data, we can get a p-value of 0.6343. So since our p-value of 0.6343 is large enough, we do not reject the null hypothesis. We can conclude that the customer's ages do have a normal distribution. So next we want to construct a 95% confidence interval. We can see through jump that our confidence is 27.262 and that the upper bound is 35.617. So, and this is also shown in the confidence interval section. So we are 95% confident that the population mean of customers' ages is between 27.26 and 35.61 years.